Hello everyone, welcome to the video series of Checkpoint Firewall configuration. In last two videos, we saw how we can connect to Troika iLab, and then we did the initial configuration on the Checkpoint Firewall interfaces, and we did add couple of routes which are required to set up this topology. And then in the end, we tried to reach the subnets, which is 136.1.121 and 136.1.122. So we were able to reach R1 physical IP address, we were able to reach R2 physical IP address, and we were able to reach internet. But we were not able to reach loopback addresses of R1 and R2. So that we will see why it was happening, why we were not able to ping. And plus, in this video, we will start the configuration on the security policies. So I'll replicate all these tasks which are there in the assignment. So it says create your own policy package by giving your name, example Sahil. So I have created a policy package with the name Troika. So it says now update topology information for all the trusted subnets in your network. Then network objects has to be created for 150 loopback, 160 loopback, and for R1 and R2 physical addresses. And then one internet access group has to be created with these three services. And then task 1 says configure policy to allow management access from your base machine to firewall for SSH and HTTPS. So let's start from this task, and then we'll complete all these 7 tasks which are there in this assignment. So let me go to the RDP machine. So IP addresses are configured. You have seen this in last video. So I'll quickly go to the smart dashboard. I have created a policy package with the name Troika. Now create a rule and give the rule name as management. Now source is network object, which should be net-192.168.70.0. Network address is 192.168.70.0 and subnet mask is 255.255.255.0. In this case, it says there is another network created, so need not to create this. Let's use the existing one. Okay, so destination should be the firewall rule, firewall object, which is CP port 1. Service should be HTTPS and SSH. And action is allowed. Logging enabled. So that's first rule, which is the management rule. And then second task says configure stealth rule to block the traffic to firewall from rest of the IP addresses. Okay. So right click, add rule below, give the rule name as stealth. Anyone, and then destination destination would be firewall object, service any, action drop, and logging enabled. So that's the stealth rule. Direct access to firewall should be denied, and exception to this is management rule. Okay. Then task number 3 says create a policy that router 136.1.1.21 should be able to do telnet on 136.1.1.22.12. Okay. And then there is a okay, let's implement this task 3 first. From R1 to R2, telnet should be allowed. Right click, add rule below R1-R2. Let's see if we have objects created. Let's see what is there. Okay, so we have internal router. So we need to select internal router here, internal router 1. Perfect. And then internal router 2 should be the other R2. Yes. So let me try to drag and drop. It is not working. So let me select from here internal router 2. Service required is telnet. Okay. Action accept and logging enabled. So let's first test these three rules, and then we will see how we can implement another task. So click on install policy. So C++ configuration will be converted into inspection script, and then we can do a test. So I should be able to access firewall. So currently CP port 1 policy package is installed, and that is now being overwritten with Troika. So we are okay with that. So click on yes, and let's wait for a few seconds till the time policy is pushed, and then we'll run a couple of tests. We'll try to do the SSH to the firewall from the space machine, and then from R1 to R2 we will do a telnet, and then we will verify the logs in Smart View Tracker. Okay, about to push. Let me right click on new session, and once that policy is pushed, we will first verify management access 192.168.70.102. Okay, let's try this. I can SSH, so that means my management rule is working fine. So let me log in to the firewall as well using password admin and user admin and password admin123, and I can log into the firewall. Now I am on R1. If you can see, let me quickly verify if we have default gateway. Yes, we do have 136.1.122.12 as the IP address of R2. We should be able to do telnet. So I can username VYOS, password VYOS, and if you execute show interface, we are actually on router 2. Let's quickly go to tracker and verify the logs. So it is loading. You guys know how to filter the logs, so we will create a filter based on the source IP address field, and then we should be able to see this telnet connection from R1 to R2. Let me close the session. So we are back on R1. If you see show interfaces, we are back on 70.11 and 136.1.121.11. Logs are there. If you could see telnet internal router R1, internal router R2, policy number 3. So source is R1, destination is R2, destination port 23, source port is this, traffic came via interface Ethernet 1, and that traffic is being allowed by policy number 3, and rule name was given as R1-R2. That's good. Now next task says create a policy that R1 loopback should be able to ping R2 loopback. So from this here to here. Okay, so let's go to dashboard. Another rule, ICMP test. So this rule is required to replicate next task, which is for the SAM database. R1 loopback. So objects are already there, so I feel somebody has used this lab and created these objects. So in your case, there might be a in your case you might need to create these objects. So let me use existing objects, R1 loopback, then R2 loopback, service ICMP, select ICMP as a protocol, action allowed, logging enabled, and install policy. Good. Okay. Now we need to do a ping to 160.1.1.1, then source interface to be used as 150.1.1.1. Perfect. So let's wait policy to be pushed, and once policy will be pushed, we should be able to see response back from R2. About to finish. We are at 70%, so few more seconds and we should see response coming back from R2. Now it's on 84%, and done. So this firewall, interesting. There is no response. One thing we missed before we started creating policies, we should have been updated our topology. So you guys need to update the topology first and then start creating policies. So I'm assuming there is some issue with the interface topology configuration. Yes, if you see here, 136.1.121 and 136.1.122, these two networks are configured as this network. So that means topology is not updated. So go to get interfaces with topology, and now we should see some routes 150.1.1.10, 160.1.1.10. Perfect. Click on accept. Now it has been modified. One is external, one is this network, and two are with static routes. Perfect. Okay. And if you see, when I initiated traffic, we should see a drop. That's interesting. Address spoofing, because interfaces were not updated with 150 and 160 information. Okay, so we have now updated topology. We need to install the policy again, and we should be able to see a response back in few seconds. Let's wait. So let's see. So we can see policy is now pushed, and we could see response back from the router R2. So R1 can ping now R2. If you will see the logs, so we can see ICMP working now from R1 150.1.1 to R2 160.1.1. That's good. Next task is create a SAM rule to block an intruder IP address 150.1.1 who is generating malicious traffic. So let's assume 150.1.1 is a malicious IP address and try to block that IP address using SAM database. Perfect. So we should keep this running, ICMP running. Go to checkpoint firewall, then monitor, and let's try to block this 150.1.1.1 IP address. Let's wait. Okay, we need to go to tools, then suspicious activity rules. Click on add source IP address. This time is 150.1.1.1, which I want to block for next 1 hour. I don't want logs to be generated. Action is drop, but no logs to be generated. Okay, click on enforce, and the rule is enforced, and this doesn't require any policy to be pushed because this rule directly goes to the security gateway. This is not getting saved on security management, so no policy push is required. And if you see here, there is no sequence number, there is no ICMP request number after 245, so that means traffic is now getting dropped. Let me try again. So ICMP is being dropped, and interestingly there will be no logs because we did configure no logs has to be generated for this traffic. Let's say, for example, now you want to see why the traffic is getting dropped on a firewall. So let me show you one command which will be very helpful in the troubleshooting. But for that command, you need to go to the expert mode. So first, let me set the expert password. Lock is with web GUI, so let me take the lock first. Lock database, override, set expert password. It should be same, admin123, admin123, then expert, admin123, fw space ctl space zdebug plus drop. So that's the command to capture the drop traffic, and I want to filter the traffic for this IP address. So we should see some package. Here it is. So 150.1.1 is trying to access 160.1.1, and it says reason is SAM filter drop. If you have not enabled logging for such traffic and still you want to see why the traffic is getting dropped, you can always use this command, fw ctl zdebug plus drop pipe grep 150.1.1.1. That's good. Let me again remove this rule, and we should see in a moment that ICMP is now working. Perfect. Uh, Now what is uh, task number 6? Create another loopback, and then R1 loopback should be able to ping R2, and then verify in smart view tracker that from R1 it should be blocked. So we have already seen that when 150.111 was not part of topology, so that's the same task. You can try to replicate this. And then we have a cleanup rule. The moment, for example, let me show you. We did allow ICMP and telnet. If I'm trying to do 136.1.122.12 on port number 22, I'm trying to do a telnet. So we should see firewall is dropping this traffic because that's not there in the rule base, and that's interesting. See, people from internet started doing brute force on the firewall. Anyways, leave this. So we should see traffic getting dropped on port number 22. Let's put a filter here. SSH. Perfect. Okay. So, okay. I feel we do not have a cleanup rule, yes. And cleanup. Okay, any drop, logging enabled, and let's push the policy. But if you see in logs, people over the internet have started doing SSH on the firewall. Some of the traffic is getting dropped. Interesting, because we have a stealth rule. So that's the reason. See how many requests are coming in from the internet to this public IP address. So many people over the internet trying to log into this firewall. So they are thinking, they are assuming this is a production firewall, and they are trying to brute force. Amazing. So you should make sure once you are doing your practice, you should have a stealth rule, else somebody over the internet will be able to do SSH, and we have a default username and password, and they might be able to log in. Okay, it's almost done. Perfect. And let me do a telnet again on port number 22. This time we should see logs, and that's my log this time. It says traffic is getting dropped via cleanup rule. Okay, so that's all in this video. So I wanted to show you how we can create policies, how to deal with anti-spoofing, how to deal with stealth rule, how we can block the IP address using SAM database. Thank you very much for watching this video. Hope you are enjoying this video series from Troika System. Thank you very much.